Hello guys, it's Johnny time and welcome to another smart contract hacking tutorial. Today we're going to solve the 9th challenge in Ethernaut, which is King. We're gonna use Foundry framework to solve this challenge, so you get 2 birds, 1 shot. You learn smart contract hacking by doing CTF and you learn the Foundry framework. Now before we start, make sure to subscribe to the channel and hit the bell notification button, and also watch the first video in this series where we set up our Foundry repository and Foundry structure and show how we solve Ethernaut using Foundry. Now without further ado, let's get started. So this is the King challenge. We should become the king. And let's see the description of the challenge. The contract below represents a very simple game. Whoever sends it an amount of ether that is larger than the current price becomes the new king. On such an event, the overthrown king gets paid the new prize, making a bit of ether in the process. As Ponzi as it gets. Such a fun game. Your goal is to break it. When you submit the instance back to the level is going to reclaim kingship. You will be the level if you can avoid such a self-proclamation. So in this king challenge, we should be the king. We're supposed to become the king, and not only become the king, but make sure that when we submit a challenge, no one else, including the Ethernaut Factory contract, can reclaim the king or the kingship, whatever, proclamation. So we need to be the last king, right? We should be the last king. No one else could be king after us. And we got a small hint because we see that on such event, the overthrown king gets paid the new prize, making some ETH in profit. So the previous king gonna get the new prize. So this is the smart contract, and before we observe it and see what kind of vulnerabilities we can find inside, I'm going to click here, get new instance, and deploy basically this new instance using my MetaMask wallet. And meanwhile, I will copy the smart contract code, go to my Foundry folder. In the source folder, I'll create a new contract. I will call it king.sol, and just going to paste here the smart contract, so we have it in our local repository in a very nice way with syntax highlighting and everything. So let's see how this smart contract works. First, we have the address of the king, we have integer of the price, and we have an address of an owner. In the construction, we set the owner and the king to the message sender, and we set the price as the message value. The constructor is obviously payable. Now here we have 2 functions. One is a simple getter to get the king, so it's a public view function that returns the current king, and this default receive payable function, which anyone can trigger by sending ETH to the smart contract. This function first check that the message value is either greater or equal the current price, so we cannot send value that is lower than the current price, or the message sender is the owner. So the message sender doesn't need to send any value, you can just bypass this require statement because we have here an OR. Then we are trying to transfer the message value to the previous king, and we change the king and we change the price. So we update the price and update the king. So this is kind of a game similar to an auction smart contract, but not really, because we can actually send the same value of the current prize or bid or whatever you call it. We can easily become the king, but we don't need only to become a king, we need to make sure that no one else can become a king after us. Now, how are we going to do that? This is going to be some kind of denial of service attack, DOS attack, and DOS attacks in smart contracts and in cybersecurity in general is a huge topic, which by the way, we cover in the complete smart contract hacking course in chapter 18. We have 30 different huge amazing chapters and more than 50 hands-on exercises that you can practice every single concept over here in the syllabus. We also have guest lectures. We have a certificate which you get upon completion of the course that will help you increase your chances of landing a job in the industry as a Web3 security researcher. And you also get access to the most amazing Web3 security community with other students and professionals where you can ask questions, make connections and networking, and meet new people, team up for audit contests, and so much more amazing things. So if you want to get access to this amazing course and all those benefits, check out the link in the description below for a special discount. Now going back to our challenge, we need to somehow cause a denial of service attack to this receive function. So in order to become the king, we can simply just send a value to this contract that is greater or equal the price. We can actually send the price. But we also want to make sure that no one else can replace us as king. So the way we're going to do it is, instead of just participating in the game and sending transaction to the receive function from an EOA account, we're going to do that from a smart contract that is refusing to receive ETH. If we will play the game and we'll become the king and the prize will be our message value, then the next person that will try to become the king and send the same message value or greater message value will fail. Why he will fail? Because this line of code will try to send us the current message value, the price, because this is how the game works, right? Every time a king is being changed, the previous king is getting the message value and using the transfer function. Now, the transfer function is a deprecated function because it's limited with 21,000 gas, and also if a smart contract that rejects ETH, that doesn't have a payable function or a receive function, then this line of code will be failed and the whole transaction will be reverted, which means that we can prevent anyone else from playing the game and becoming king. This is also called DOS, or denial of service attack, because we deny the service from anyone else. Now, this is a very interesting attack vector, DOS attacks on smart contracts. And again, if you want to deep dive and do a lot of exercises and learn all the types of different DOS attacks and all the other amazing chapters, you should definitely check out the smart contract hacking course. Okay guys, so we're going to solve the challenge. First, we're going to copy a script file, just a random script file from the previous challenges. I just chose delegation and I'm going to rename it. Instead of delegation solution, it will be king solution. Perfect. Now we need to change some things in this file. Instead of importing delegation, we will import the king smart contract. The contract name will be king solution. And here, this will be king instance. And this will also be king. Now here we need to put the instance, the address of this challenge. So we'll go back to Ethernaut, open here the console, and here we have the instance address. After we clicked here previously get new instance, it was deployed for us, and this is our address. You can also do contract.address to retrieve it, or just instance in your console command. It will be the exact same value. So we're going to copy here, make it payable, because the constructor over here is payable. So we have to define this address as payable, and also it has a receive function. So that's what we have over here. I'm going to remove all this code and leave only the start broadcast and stop broadcast, so we can make sure that our Foundry local repository can broadcast the transactions using our private key, our MetaMask account, to the Goerli blockchain. If you are not sure how this works and how the Foundry works with Ethernaut, check out the first video again in this playlist. As I mentioned before, we need to create a smart contract that will play the game. We cannot do it inside this smart contract because this smart contract is actually gonna just send transactions. This is how Foundry script works. And we have to create another smart contract. So I'll create here another one. I will call it the last king, because this contract is going to be obviously the last king. We're going to prevent anyone else to become the new king. I will define here the constructor, and in the constructor I will receive the king instance so I can interact with it. So it will be king underscore king instance. I will pass it from this contract, from this script file. I will pass it from this contract, from this script to this newly created contract, and then I will interact with the king contract and play the game. It obviously needs to be payable because we need some ETH to play the game, right? Payable. We don't know what is the current, actually the current price upon deployment, what is the value that is being sent here on the constructor. We can go to the blockchain explorer and check it, or just check the balance of the smart contract, but we can do something much more simpler. Since price is a public variable, we can actually access its getter, because by default every public variable in Solidity gets a getter, so we can just call the getter to get the current price. And we need to do a very simple thing here in the constructor. We just need to send ETH to the king smart contract. So let's just do it. So we'll do address king instance, and then we'll use the call opcode to create a smart contract call together with value. We're not going to use the transfer because it's deprecated, and if you want to learn more about transfer and send and call opcode, again, go to the smart contract hacking course. It's out of scope now for this video, but we're just going to use this low level call opcode in order to send ETH to the King instance smart contract, and the value that we're going to send is the current price, because it should be enough, because in this if statements, if the message value equals the price, we're going to bypass this require statement, not if statement, require statement. So the value is going to be here King instance dot price. We're gonna retrieve the getter of the price, the public variable price, and we are not gonna send any data in this low level call, because we don't want to trigger any function, but we want to trigger this receive payable function. Beautiful. Now all we have to do once we have the contract that will play the game, just to deploy it and send the price to it, the if, so it can forward it to the King instance. So I'll do new the last King, and the value again is going to be value King instance dot price. Again, we're going to fetch the price from the King smart contract, pass it to our new constructor, and then it will be forwarded to the King smart contract. And don't forget, we have to send here the King instance himself into this constructor. So we're going to send it over here, and that's supposed to be enough. This is our script solution, clean, beautiful in Foundry. We explained every single thing, and now it's time to run the script and broadcast it to the blockchain to see if we can solve the challenge. So in order to solve the challenge, I will execute forge script. It will be the solution file, King solution -- broadcast. And we also need to add here TC. TC stands for target contract. Since we have two smart contracts here, we need to tell Foundry which contract to execute, and we obviously want to execute here the King solution. So I will pass here the parameter King solution, click enter, and cross my fingers. And of course we have an error, we have a typo over here, so this will be King instance. I will just copy, make sure it's the same variable name, and try to run the test again. No big deal, right? We will wait a little bit. Now the transaction was sent to the blockchain. We are waiting for some receipts here. Once we get one receipt, one validation, we can go and submit the instance and see if it worked. Beautiful. We got our receipt, which means that we can head over back to Ethernaut website, submit the instance, send a transaction through MetaMask, and now we'll have to wait that this transaction will be validated and see if we were able to achieve the required states and no one can claim the King position. We're gonna be the last King. And we did it again, guys. Oops, we did it again. Well done, you have completed this level. We solved this amazing King challenge, and if you enjoyed this video and you want to get so much value content from this channel, make sure to subscribe to it and turn on the notification button. Also, click this small like button so many more people will be exposed to this video and learn smart contract hacking together with Foundry. Thank you so much, and I will see you next time.